Welcome
to the joy of coding.
Hello, and welcome to episode 279 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. Gonna be hacking on some Firefox stuff today. Gonna be looking at some neat infos. Maybe clearing out some expiring probes or updating, bumping some expiries, going through that. And then there's some more work related to video controls that I thought we might look at today. So let's take a look. Let's dig into it. What's going on? So let me start by sharing my screen. Okay. Oh, and there's like this gap here. That's unfortunate. Come on. Where is this coming from? Sorry about this gap. Oh, no, it's the microphone. It's the microphone. Okay. So yeah, no plan survives breakfast. That's the first thing I want to make sure that I make clear. If you're new to the stream, that's something I say every time I start, because it's very important for you to realize that most, if not everything that I do during this stream, with the exception of saying no plan survives breakfast, is unplanned. I don't really have a sense of how things are going to go today. We might get blocked on the very first thing we work on. We might get sidelined, rabbit holed, or we might blast through all of it and need to find more things to do. That's okay. I'm happy to just kind of have you watch me muddle through going through my daily work. Like I'm going to be doing things the way I would do them if I wasn't recording myself effectively. But I am going to be speaking out loud. That is the other difference. So, might get stuck. That's okay. The second thing is that the agenda that we're looking at is available to you. If you're watching this on YouTube, check out the video description. If you're watching this on Air Mozilla, check out the details section. And if you're watching this on Twitch, I'm going to grab the episode agenda here. And I'm just going to drop it in the Twitch chat. There it is, 279. And that's it. I'm just going to blast past the episode guide. I will mention there is an episode guide if you're watching this in the future and want to know what got covered today, or if you're watching another episode at some point and you want to know about what happened in a particular episode. Maybe you want to search and find the subject or an episode where I talked about X or Y or Z. The episode guide is your resource to help you find those things. It has copies of the agendas. It has additional information. And I wanted to point out that the episode guide is something that you can contribute to. If you have your own notes, addenda, corrections, anything at all that you want to add to make the episode guide more useful to the people who are using it, I highly encourage people to send pull requests to the repository. Special shout out to Smurf D, who I know is watching, for being such a prolific contributor to the episode guide. And Smurf D also points out that, there was a FOSDEM talk I did. So Smurf D is in the chat and reminded me that not last weekend, but the weekend before that, I did a talk for FOSDEM. And FOSDEM, if you're not familiar with it, is an open source conference that happens in Europe usually. This time it was remote, and I happened to do a talk. It happened on the 5th and 6th of February, and the recordings are all available, I believe. If we go to the dev room and we find, where's Mozilla, let's see, view the schedule for this track. We find, so there are a couple of great talks here. I think I've already linked to this before, but I'm going to put the link in here for people who maybe didn't see it. And I believe all or some of these videos are now available. So let's just pick on the Search Fox one. Let's see if this is available to watch. Let's fast forward. Yeah, there we go. There's Emilio. There's Emilio talking about Search Fox. I actually was not able to see all of Emilio's talk, so I'm very happy. I'll be able to watch the rest of it. And then there was I have my talk. It should be up and available here. Let's check. Android looks like it. Who's this fool? There we go. And so go check those out. The recordings are all up, and it's not just definitely check out the Mozilla ones, but you can check out all the tracks. There are a bunch of probably very interesting videos, so they're all available for free. You didn't need to attend. You don't need to log into anything. You can just go ahead and watch them. So I'll put, if you're curious about my talk, I don't want to plug myself too much, but there you go. I wish this would auto-link. It would automatically create links. But there you have it. All right. What did I want to do today? Well, I want to clear out some neat infos. So in Bugzilla, there's this feature where people can request information from you, and my neat infos are starting to queue up, and I thought we could go through some of them. I just have to find the ones I was thinking of that we could go through today. Oh yeah, there are some that I think are just automation for like. Yeah, here we go. Let me start opening these as links. The only reason I'm doing this off screen is because my dashboard also has security bug stuff, and I don't want to share that. So just give me a second here while I open these. You know what I'll do actually is I'll open them all in this window and then drag them over. Need info here. Need info here. Lots of neat infos. So we're going to be going through all of these neat infos. And what's this one? This is Talos. Okay, we'll see if we can make sense of any of these and push some of them forward. So I'm going to drag all those in. Bing. Okay. So the very first neat info I was going to look at is this one. The neat info was set 7 days ago. It's actually an automation bug that was filed by the thing. There's a bot that checks to see which telemetry probes are set to expire soon that I have my name on. And this is one related to the time to close tabs. This is a performance probe. And I'm actually we've renewed this probe before. In fact, if we look through our if I open up the Joy of Coding episode guide, it's possible I've renewed this probe before. Have I? There, episodes. No? Okay, well at least I don't seem to have mentioned it in a previous episode. Oh, so I have episode 99. Let's look at episode 99 and see what happened. In episode 99, you were getting all prepped to do the 100th episode, and then I did something related to these probes. Maybe did I land these probes around here? Let's find out real quick. I'm very curious. For unload, update, wait for browser, permissions, regression tests. Oh, who knows? Who knows what I was talking about? Well, at any rate, we have to update these probes now. So let's first start by putting our link in here for the bug that we're going to be working on, and then let's take a look at the definition of these probes. And the reason we do this is because, you know, we don't want to just sort of accumulate probes and just always be accumulating and always be accumulating. You can get, like, this forces us to reevaluate the usefulness of probes periodically and, you know, throw away the ones that aren't useful anymore. And it looks like we've renewed this a couple of times. The last time was 1730041. Now, this is a probe that I think is still useful. You can still close tabs. This was last done 5 months ago. So I'm thinking we're probably going to renew this again. But what I think I'm going to do is I'm going to see whether or not our product team is interested in making this a permanent collection. You know, is it ever likely that we're going to not want to measure the performance of closing tabs? Well, that's a good question. So that's what I'll start with, and I'll also link to see also. Oh yeah, it already linked it up to the previous one. That's very nice. So what I'll do is I'm gonna need info Roman. Hey Roman, do you think it's worth making these probes never expire? They measure the time it takes to close tabs, and permit unload time. Which one is that one? What does that one do again? Histograms. Time taken to run a permit unload on a browser during tab close to see if we're allowed to close it. They both measure the time it takes to close tabs, although is measuring how long we wait for sites to run there before unload events, before closing a tab. Do we think it's or do we otherwise I guess that's the question. Do we want to make these probes never expire? So I'm going to request that information because that will change how I approach this, because it will change the form I have to fill out. All right, next one is related to the About Home startup cache. These ones are about to expire too. I'm going to try and bump these. We have not yet let the cache ride the trains. I haven't had time to make that happen. It's sort of been a side project of mine, so I'm just going to bump these, and that's pretty straightforward. So the way you do that is you find the probe in where they're defined. In this case, this is a histogram, and we're going to start by adding the bug to this list, and then we're going to say which version we want this now to expire in. So let's look at the release calendar. Let's extend this probe so that it expires 6 months from now. So sometime February, March, April, May, June, July, August, sometime in August. So that'll be probably version 106. Let's do that. Version 106. And otherwise, I think that's it for that. There are a couple of other probes here. About Home cache result. These are not histograms. These are, I believe, scalars. So we're going to have to go and find our scalars. These are defined inside of YAML files. And we'll add our bug number here. And we're going to say 106. And this one down here, shutdown right, and 106. And we can probably reuse the form that we used to renew it last time. Oh, I already had it open here. So we can reuse this data collection renewal request form data. We'll just, let's see here, data renewal request .md. And let's paste this stuff in. Provide a link to the initial data review request. That's done. When will the collection now expire? And this is still relevant here. So I will request data review. I'm going to request it from one of my colleagues who's one of our data stewards. Corkadale. Megan McCorkadale. Here we go. And we're going to take this bug. And then we can post this patch. Looks good, looks good. Bug such and such. Bump expiry on About Home startup cache probes. And who will I have review this? Let's have Nicholas review this one. Just picking someone. And because I know Nicholas recently did some probe stuff, telemetry, and so submit, tip, post that for review, and we'll move on to our next one. Easy peasy. These are not hard bugs or hard need infos. These are just like, it's almost just like little chores. Okay, so this one might be a little bit more of a struggle. We have an intermittent test failure. Browser devices get user media unprompted access. Application times out, and it looks like this has been an intermittent. This was filed 9 months ago, so less than a year. If we look at just a random selection of the frequency, it's been not that frequent. 3 failures for every 2,000 some odd, 7 failures for every 2,000, 39 failures for every 3,000, and then can you please take a look at this? Yanni Varson's related to Get User Media. There have been 50 failures in the last 7 days, so it's becoming more frequent. Appears to be related to running with privacy WebRTC legacy global indicator is true. I've run some more local tests. When privacy WebRTC legacy global indicator is true and headless, the first test always seems to time out waiting for promise message OK. Here. This test is failing. Promise message OK. What is promise message? Is there a promise message? Will use content task spawn to add an event listener. And then return a promise when the data matches the expected message, in this case, OK. And when is that OK message sent? Presumably that's something that there's like a test page or something. So in here where we have content test WebRTC, there'll probably be something like post message. Message. So message OK. So it sounds like that'll happen after a call to request device. And what calls request device? Presumably there's this function called promise request device. I see. I think I see. Where's the request device? Message OK. So we do set it up properly here where we content task spawn and then promise request device. How does that work? Promise request device. Where is that defined? It uses special powers spawn. Which is different from content task.spawn. Spawn, which is going to load a frame script. Interesting. And it sounds like Michael Froman, it always seems to time out waiting for this. If I remove that test locally, the other tests seem to be okay. So let's try doing that ourselves. Can we reproduce the behavior that Michael Froman is seeing? Trying to remember how one tests the, was it browser components? No, browser. Where's the test? Browser base content test WebRTC. Base content test WebRTC. And then there's one called legacy indicator. And then I can say start at, what was the test? Check audio. Browser devices get user media unprompted access. That's the name of the test we want to run. Start at and at, I think it's the same one. Let's just see if that'll run, first of all. Unknown command. Whoops, I forgot to say mock. Moki test. Scooby-Doo. Does not like it because it does not know about this test. I wasn't even talking about browser tab bar visibility. Do I need to do a build? Build with artifact. Mock build. What are you talking about, browser tab bar visibility? I was not talking about that test. Such a test doesn't even exist anymore. I wonder if that's maybe related. Maybe there's some kind of cache that's out of date. So let's quickly do an artifact build just to double check. Smurfy says, guess you'll use headless next. Just want to see if it runs now. That is correct. I just want to make sure I can run the test in approximately the same conditions before I really try and reproduce the headless thing, which seems to be the trigger for what Michael Froman's been seeing, or those conditions. And if we can get that, well, if we can get the test to fail, we're in actually a pretty decent position to investigate what's going wrong. All right, while we wait for that, let us move forward a little bit. Take a look at some of these other ones. Reevaluate sync startup timing. There's a long conversation in here from 3 years ago. Started 3 years ago. Sync tries pretty hard not to interfere with startup. I'm not going to read all of this out to you, but it sounds like if I just kind of like blur my eyes at this, we wait far too long to start talking to sync on profiles with lots of tabs. It's about ripping out all that old stuff, just making initializing sync happen on an idle task when the browser starts. Okay. Let me see what the actual question is. So around 8 hours ago, Heis asked me, I think I was misleading here. What is the design? What is in the design is an attention dot on some piece of UI, a bit like one on the hamburger menu for updates, indicating things are available from tabs from mobile. No desktop notification spam will be involved. I don't think that startup isn't a concern at all. Startup isn't a concern. Let's just do a full sync very soon after startup. Arrange for tabs to be the first thing synced, then remove all this code completely. But I think waiting 5 minutes is way too long and not much better for startup times than waiting for CPU idle after we finish creating all the tabs. In other words, I think that, doing the initial sync from startup idle tasks would be a good compromise, not interfering with startup performance and still doing the sync relatively soon. And so Heis is talking about this queue, startup idle tasks. Scheduled tasks need to be run only once after startup and can be scheduled by using an idle callback. They will fire from idle callbacks once every window is finished being restored, and it's guaranteed they will run before the equivalent per window idle tasks. If you have something that can wait even further than the per window installation and is okay with, or initialization is okay with not being run in some sessions, please schedule them for schedule best effort. What is best effort? Function. We call it from an idle observer. So what we do here is we use idle dispatch. Which we're okay. Versus, what was the other one that I was suggesting? Startup idle tasks, which uses, which was this use? Also uses idle dispatch. I wonder if, when is this one called? If the user becomes idle, then we do schedule best effort user idle tasks. Can you give a second opinion on the startup impact, or if there's a better place? I think the function that you link to, which is, I think, what is this function called? Schedule startup idle tasks. Schedule startup idle tasks is a reasonable place to put this. And I'll link to the code. It'll wait until we have time to service non-urgent events, which should be long after. Should be after most of the critical work for starting the browser. Should be after the critical work of starting the browser and making it responsive. There is also the option of the other idle one, which is schedule best effort user idle tasks. Which has the added bonus of waiting for the user to become idle, not send any input events, user input events to the process for some time. The drawback there is that if the user never becomes idle, then sync would never start, which is probably not what we want, right? Like, that's hope. Wait, task idle time, see the current value of this idle observer. This function may never be called if the user is never idle for the time. 20 seconds. Not saying use the pronouns for 20 seconds of time. That's probably not what we want. So the first option is probably best. The one you identified is probably best and was yeah. Putting start, it seems it's exactly the sort of thing. Sync is exactly the sort of thing that would fit in with that function's purpose. Okay. Let's see if our build is done. Let's see if we can run that test now. Scoop-boo-ba-doo-doo. Boo-doo-ba-doo-doo. Could not find any Moki tests under there, which is interesting because there definitely is a directory. So what I'll do instead, because I'm pretty sure I can just run the directory itself. Like if I just do mock Moki test browser content test WebRTC legacy indicator, I think that'll run it. That'll run the manifest. Oh, that's what I needed to do. I needed to pass the manifest. Browser.ini. I forgot that it would accept the manifest file. So now it's running some other test. Okay, that was more tests than I thought it would run. Yeah, it's running way more than I thought it would run. So it wasn't paying attention to my start at or end at. Oh, that's maybe because my end at was poorly written. Let's try that one more time. it runs another one. Okay, significantly shorter, and I think that's ultimately what I care about. Now let's run it with headless. And see if that thing fails out on us. It does not. Well, the other option is to test it on Linux. So let's look at the question again. Always seems to time out waiting for promise message. Okay, here, if I remove that test locally, the other test seems to be okay. Since you split these tests into legacy versus new, do you have any thoughts here? Should we simply disable get user media unprompted access on Linux for the legacy indicator case? What is this test testing? Unprompted access. Oh, I guess if the user has already requested a given granted permanent permissions, we would expect the devices to just excuse me, cause a prompt. Well, I do think we still want this test coverage. What I'm going to do is I'm going to sign into my Linux machine. And it looks like I had some kind of GDB thing going on. I don't think this session is useful anymore. We're just going to exit from all this stuff. Exit, quit, don't need it. Don't need it. Quit. Yes. Quit. Quit. Exit. Quit. 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 All right. And let's see if we can recreate the issue here. Now, my Linux machines, the disk space, I'm starting to run out. So unfortunately, I can't keep an objdr around, like more than one objdr around. I need to repartition the drive and increase the disk space. I really need to do that. But in the meantime, I'm going to blow away my debug objdr and make an opt build. What is it? What do I call it? Artifact build? And then build that and see if we can reproduce the issue over here. So let's move on while we wait for that to build. So we answered that question. Auto-played next video should also be pip. So I was need infoed on this. Lack of updates. After that, the patch should be included. I intend to revisit this patch soon. Bugs, I didn't log in to Bugzilla in the last 7 months. Right. Can you have a look, please? Looks like Catherine is will come back around to this. See comment 11. Clear that need info. Here's another one. So this bot is just going around finding bugs that have been assigned but haven't been touched in a while, unassigning people, and need infoing me. And this one, it's make sure that the picture is destroyed before moving to the next test. I'm gonna say this is a severity NA. This is like, yeah, this is P3. I think the priority of P3 is correct. This is more of a this is not a user perceivable issue. It's more about a way of making our tests more reliable. Okay, next. How's our build going? Oh, our build's done. Okay, let's try reproducing that test failure. Oh man, hang on. I gotta get the, what was the exact command? It was this. So I'm gonna, I guess I'll do that, yeah. Oh, come on. Seriously? Let's try that again. Please don't lock me out. Please don't. Thank you. Okay. All right, let's try that. Let's hope that this fails. Aha! Excellent. Okay, we're in a position where we can diagnose this. Let's diagnose it. So what we'll do is, there were a couple of interesting things here that we were waiting on. There's this content task spawn from this function called like promise message okay. It was this promise message okay that wasn't resolving. So let's find the definition of promise message, which I think was in the head function. Promise message, and that uses content task spawn. So let's do that. WebRTC browser, no, head.js. Promise message. So waiting, setting up listener for message a message. And then listen for message, dump, saw message, resolving listener for message. All right. And then message, and it returns a promise. What do we do with this promise, by the way? Oh, return promise.then. I see. Okay. Okay, so that was the first one. The second one was that request devices. Promise request device is. I think that's what the test was doing. Promise request device. And then it uses, yeah, request device. Okay, so that's what we're going to do next is we're going to log this stuff. There, it looks like we already have an info string here. So I won't need to do anything else, but like let's put some logging here, like requesting device, and then what I'm more interested in is the function request device that is defined inside of that web page. No, hang on, no. It's like I want the utility function that's defined in the content right in one of these. I'm not sure which one it is. Which page gets loaded for this test? Which page gets loaded? Tests. Run. Promise notification shown. Which one is being loaded? Is it get user media.html? Test page. Open new test tab, which presumably from run tests. Okay, so we're going to be using get user media. That's the one that we want to log this request device function. All right, browser-based content test WebRTC get user media.html request device. Whoop. Request device called, and it wants its shirt back. And then what we're going to do is we're going to sending message, sending OK message. Okay. I don't think I need to build, but I'll do it anyways. All right, let's see what happens now. Okay, requesting devices, requesting devices. Saw a message, okay. Request device. It didn't send the okay message. Setting up listener. Then we set up another listener. What listener are we listening for here? Like we have a listener here, saw a message, set up a listener, saw a message, resolving listener. So what are we waiting for here? Let's go back to, no. Where do we want? What was this? Browser, devices, should have all this open. Devices, get user media unprompted access. We promise a message here, 1. Promise a message here, 2. Are we certain that we're hung up here? Is it possible? Checkpoint. This is an old technique. Let's see. Checkpoint 2. Let's see where we're breaking down. Checkpoint 3. Very old technique. Checkpoint 2. We didn't get to checkpoint 3. So somewhere in here we're breaking down. All right. Checkpoint 2.5. Is it before or after? We're bisecting the space to see where we're breaking down. We're after 2.5. So somewhere in here. 2.5. Checkpoint 2.6. Checkpoint 2.7. Nothing shameful about printf debugging. So we're going to see which one of these we waited for. Whatever gets you the information that you need. It's this one. This is the promise that a pop-up notification was shown. Ah, well, maybe that makes sense because if we're headless, are we able to show pop-up notifications? What happens if we don't run headless? By the by. Yeah, I've got the display set up. Okay. curious about something. This first mode is with the legacy global indicator off. And we care about it failing when it's on. You know what I'm going to do, actually, is browser-based content test web RTC browser.ini. I'm going to turn it on. And then, instead of doing this wacky thing, I'm just going to say, just run this test. Mock Moki test headless. Yeah, Smurf D says headless usually means you don't need a modder, so maybe a pop-up does not make sense unless you have other headless tests allowing pop-ups. We do have things that are like pretending to be pop-ups. It's that I suspect the thing that's the code that's expecting to be able to get displays in Windows is failing in that particular test because the Firefox window doesn't exist. But I think that's peripheral to, like, that is a side issue. I think what we've just stumbled on, we've now recreated. It has taken some time, but we have now recreated the conditions that Mr. Froman, is that their name? Michael Froman, MJF, had identified. It took a second, but we got there. I had to make sure that I flipped the prefs to be in the right state, but we are now like here where we're waiting for a message and then we request a device and we don't fire the message. That's the condition we wanted to be in. And request device was called, but we don't fire the message. We must send some kind of error instead. Dump error was error. We don't even get there. Sounds like we don't even get here. Where do we... Request device called. Do we not get there? Do we get here? Requesting GUM. Dump. Done. Awaiting. Is it possible that that promise never resolves? So it just sticks. Yeah. So get user media never resolves after checkpoint 1, which browser should really have them open at the same time. Browser, no, WebRTC. What was the name of this test again? I keep repeating myself here. Browser devices, get user, blah, blah, blah. Okay. So we got to checkpoint 1. We didn't get to checkpoint 2, presumably because this promised checkpoint 2. Oh, we do get to checkpoint 2. Checkpoint 2.1. Checkpoint 2.2. Where are we failing? Just to checkpoint 2 before 2.1. So waiting, we assert wait promise no pop-up notification. What is that? Base content test web RTC browser. wait for condition that a notification gets removed. So let's look at what this test actually does by then. So we request some devices and we expect the notification to be shown. And querying device events. Then we allow the devices to be shared. So we expect video and camera, microphone are shared. We wait for the indicator to exist. We check that the sharing UI is correct on the sharing indicator. We expect that these are called, I guess. We also set up a listener for the OK thing. We're going to request the devices again. We don't stop sharing. We just request them again. And this promise resolved, apparently. And then the observer promise is resolved. But the WebRTC share devices pop-up notification is still around. What does this look like in practice? Like if I were to wait here, set timeout resolve 5000. I'm just going to sleep, and then we're going to sleep here as well. Whoop. We're going to sleep, and then let's take a look at the display. We'll actually bring our display up so we can see what happens, what it looks like. So not headless in this case. What happens? SmurfD says, I have 2 checkpoint 2s. Do I? That's confusing. Checkpoint. Oh, I do. I should call this checkpoint 1.1. Make it easier. Here. Display 0. Go. Thank you, SmurfD. There's one drawback to checkpoints. So the test passes when not headless. Let's see it fail again. Oh. Wait, no. That's our 5 seconds. Oh, so I'm wrong. I'm wrong. You were right. SmurfD, thank you very much for pointing that out. I made an incorrect assumption because I had the wrong checkpoint 2 identified. Dump checkpoint 1.2. Dump checkpoint 1.3. Dump checkpoint 1.4. Is this the most effective way of doing things? Nah, maybe not. But is it giving me the information I need? Yes. Checkpoint 1.2. So we wait for this promise. So it's exactly as Mr. Michael Froman was saying. It's we just don't get that okay message, and that's because that over here, this get user media request never resolves. Quantum's saying something about why generators were superior. No. Disagree. Okay, get user media. How does that resolve? Well, a request comes up and it eventually gets piped through base content test, not WebRTC indicator. Let's see. Where's the WebRTC stuff? Browser, modules, WebRTC, UI. That's one. You could just put checkpoints between on every yield. Yeah, and you could put checkpoints between every await. It's the same thing. It's the exact same thing. Let's see. If I remember correctly, the way this works is WebRTC child. Whenever a request is made, get user media request, we'll say handle gum request. We will prompt. The way that works is it sends information to the parent process. Handle request. Then see the message on allow. We will notify when we allow or deny. I see. And that's what resolves the promise. WebRTC allow. So, I guess my next question is, it's kind of clumsy. Oh, with yield, you can just have a single line in the loop that goes over the generator. Yes, you have a generator that is yielding things. You could put checkpoints with some kind of incrementer. No, I still don't see how that's better. At least this way I know, like that's so abstract. At least this way I know where in the code I'm like set printfing, as opposed to like an abstract test runner that is like printfing every time the test function yields something. I would then have to like, I guess you could yield some kind of string to say where you are. I don't know, man. I don't know. I don't see the appeal myself. But you do you. I won't tell you how to write your tests. You do you. Generators are pretty cool sometimes. Okay, WebRTC allow is a message that could come down, but presumably isn't coming down. And where does that message come from? Well, WebRTC parent, probably. After checking if a request is allowed. So let's actually see if we enter here in WebRTC parent. I have a lot of things open right now. I'm going to open up yet another editor. And where is this file? Browser actors. Browser actors. WebRTC parent. Allowed. Check request allowed. Checking if a request is allowed. Let's see if that shows up. Is there a way I could attach a debugger to this? Oh, that's interesting. We never even get to that point. We don't check if the request is allowed. Do we receive a message from prompt? Do we receive a message from the child requesting? Parent received WebRTC request. Come for the fishes asks, am I using ZSH? I don't think so. I think I'm using bash and biobu. Let's see. Let's find out. Echo shell. Bash. I'm using bash. So the parent does receive the request. And then what happens? Do we enter prompt? Calling into prompt. And then can you, here's a question. Can we do JS debugger? Does that work for headless? No, it doesn't. That's too bad. That would have been nice if I could attach the debugger. Okay, so let's see where we get to. Do we get to here? Checking request types. There's all this stuff, all these different kinds of messages we might show. Notification stuff. We set up. Oh boy. Options, blah blah blah. It's a big function. I remember that being a pain. And callbacks and all that stuff. Now what is done with this options thing? Options.checkbox. And then here we show the notification. Showing the notification. Do we show it? I'm guessing no, because this would be the second time that we showing the notification. Oh, okay. And then what do we do? Showing the notification. Does that make sense? It shouldn't prompt. So it is prompting again. And that's why this part's failing too. That's why it's failing. It's prompting again. Interesting. So what code path does it follow whenever it doesn't prompt? This is very difficult for me to navigate. I'm gonna try and pull this up in what file am I in right now? WebRTC parent. Okay. Prompt. It's very difficult to follow, but let's see here. There's gonna be something in here about allowing the request. Notification silencing. No, we don't have that enabled. I don't believe. Oh, and we're definitely not sharing the screen, so it doesn't matter. Options. Like, when do we just go ahead and allow it? There's that, like, check allowed. Check request allowed. Who calls that? Here in if we have an add-on policy, and here's another one. If the user this is... Oh, when tearing the window out. Okay. WebRTC allow. Is that the only place? So here's another one. We send WebRTC allow if the user has clicked on the menu item to say like, hey, yeah, allow. We send allow if we check request allow is true. I don't think that counts, like that's a factor here. Unless something external is calling this. No, because this is not add-on policy. And we are not handling some kind of prompt. And so what's the other one? It's just those two. Okay, so when this test does pass, what's happening? So one thing we can do is try and make this checkpoint, like let's run this test without headless and try and get a sense of what code path we enter whenever things go well. Okay, that should be enough information. Checkpoint 1.1, requesting devices, requesting gum, and then the parent did receive the message. 1. So we got here, and it's like the parent does receive a request. Calls into prompt, checking request types. It does show the notification. Checking if a request is allowed. So somewhere, which one of these allows gets called? Sending WebRTC allow at 1. Sending WebRTC allow at 2. What is going on? All right. Request the device. Parent receives it, calls in the prompt. So it's at 1 that we decide we just go for it. It's at 1. So here inside of check request allowed, I guess that is what it's saying. Okay, great. So what I'm going to do then is dump the stack here. To get a sense of how we got here. Okay. 1.1. So after we show the panel, we call this event callback on line 797. Oh, and then it just removes itself. Oh, that's what goes on. So we always show the notification, but if like the user has granted permission, then we remove the notification. Got it. Got it. Okay, so let's now do our failing case. I have a better sense of a better sense of where we are here and what's going on. Panel event callback called with topic a topic. And then hopefully we get down to here, checking if request allowed to maybe just let her rip. Showing the notification. Checking the request types. It shows the notification, but we never got this event callback. Whoop. Show. So now we go into pop-up notifications code. Where is pop-up notifications code? Wow, this is, like I said, these need infos ended up taking up all of our time. But maybe this is good stuff. Hopefully this is interesting to you. Notification show. Show. Existing notification. Create a new notification. Update anchor items. Return notification. Then what calls the event callback? Fire callback. And the one we want is notification event showing. Attempting to show panel. Shown. Firing shown event. Showing the notification. So we never re-enter show panel. We never get here. Called update. Who calls update? Re-show notifications. Function swap browser. That one's not relevant. On pop-up hidden, no. On button event, no. On menu command, no. On show, yeah. Show the panel now is checking if active browser window. Is active browser window. Is active window. That might be related to it. I wonder if in the headless case, the indicator window has somehow taken focus. Yeah, is active browser window. It's not the active window. So, yeah, I think that's what's going on. Let's test that to be sure. Promise. Okay. Request device. Await. Simple test promise focus window. I think that'll do it. Let's see if that works for this particular case. the focused window is. So we got further. 2.6, the object cannot be found here. 2.6. Oops. Where's 2.6? Error was not found error. The object cannot be found here from something. Awaiting this promise, which was waiting for the pop-up notification to be shown. The object cannot be found here. Not found error. That's very generic. Oh, from media. The object cannot be found from the media stream. I mean, are these tests even supposed to be able to run in headless mode? Let's try one thing to make this easier to deal with. Let's do this. Browser-based content, WebRTC, because I'm kind of like dealing with some really funky stuff because of the fact that I have to go through the Linux machine to reproduce this. Let's see, global indicator, true, false, false. Okay. Monkey test, browser-based content test, WebRTC, user devices, and it was called that. Let's just run that. Oh, wow, lots of chat. Denshub would like everyone to go back to callbacks. No. Pizza Pocket asked about the Jira integration bot. It looks like there's some conversation there. There was a typo. It sounds like there's a typo. It should be integration and not integration. Sounds just like a bad mistake, a typo on our part. Someone who made that bot accidentally put in a typo. Okay. Let's run this mode with headless and see what happens. It works okay. Well, in a way, I'm not super surprised because on Mac OS, we never showed the old indicator window. That's right. It was just a Windows and Linux thing. Okay. Okay. So the test is failing here at checkpoint 2.6 because we're requesting a device and we pass. I have to remind myself what all these arguments mean. I can't stand it whenever it's just like this anonymous bag of arguments. Base test WebRTC head.js promise request device. So whether or not to request audio, no, just video. No audio, just video. Not passing in a frame ID. Oh, we're going to request screen. Yeah, that's going to fail. That does not surprise me that will fail in headless mode. I don't think we can get the screens in headless mode. So that's probably why we're failing there. So I think we've determined a couple of things. I think we've determined that this test is maybe failing in automation because the indicator window is stealing focus. And so the The indicator window is stealing focus in this particular case, and that is preventing the panel from appearing. Now, whether or not that's actually causing the intermittent test failure that this bug is all about, I don't know. But we can find out. In fact, one thing we could do is we could take a look at some of the screenshots from a recent test failure. The last failure was 3 days ago. Let's pull this up. Let's look at a test failure. They're all on Linux. So interesting. And let's pull up the details of this test failure. Let's take a look at the screenshot that's taken when the test failure occurs. Apparently we don't have that screenshot. All right, let's try a different one. Let's try this one. What? Come on. Any of these? Do any of these work? Contains errors? Come on, man. When were these? February 10th? Now let's go back a little bit further then. Please. Please give me these images. Here, let's go another page. February 7th. Oh, you're killing me. Okay, so no images. And it might be because of when the failure occurs. It's a timeout, a massive timeout. I wonder if that's the sort of situation where we don't do a good job of collecting screenshots. I can believe it. I can believe it. Well, let's see. What we can do is push to try with this promise focus the window after we request the device. Or even better, after we do promise request device, is we can build that into the promise request device helper and see if that influences the test, like if it changes the frequency of the failures. So here's what I'm going to do. Oh, update for the people who noticed the integration bot accidentally having the name integration bot. That typo has apparently now been fixed. Amazing. Now that's service. Okay, so what I'm going to do is I'm going to push to try, mock try, and I'm just going to do Linux builds. I'm just going to do artifact builds. I'm going to do mock try fuzzy artifact browser base content test web RTC. Just this folder. I think I can do that. And I'm actually going to supply a message that's like baseline tests. I'll bet you this is also going to fail because I haven't haven't added my SSH key to this session. So this is also going to fail, but at least I can use mock try again and now I have to wait for mock try fuzzy to respawn. One of the problems with mock try fuzzy, or any of the mock try, mock try is great. There are lots of jobs you can trigger, but in order to do that, it has to like compute all of the possible jobs from the build I'm on, from like the revision I'm at, and that takes a little bit of time. Like this task configuration change thing, generating the target task set, involves like scanning for all the different possible jobs I could try and create, and then that takes a little bit of time. I don't know if that information is cached in between runs of mock try fuzzy. I kind of hope it is, but I can't say I certainly haven't heard of us spending lots and lots of time trying to optimize the performance of mock try fuzzy. We spend most of our time optimizing the performance of the browser for our users, but we don't. Here we go. Okay, Moki test browser, and the failures tended to be on Linux. What is it? Linux 64 QR. Shippables are, we could use shippable, but they take longer to build. So I'll just do Linux 64 QR. We're not going to do debug builds. We're not going to do software are my options here? Chrome, browser, Chrome, software render, E10S. I don't know what NW is. Fission. Let's take a look at these jobs again. With networking on socket process with Fission enabled. So SPI, NW, Fish. Oh, this is one of the shippable ones. I don't want a shippable one. What's software accessibility checks enabled? Qopt, browser, Chrome, SWR, A11Y. Checks E10S. Perfect. I want this one. Do it. And it's going to say like, hey, guess what? No. Because I haven't authenticated my SSH key or added it to the session, but I'll do that next. But I think I'm gonna end the stream after I push. So I'm gonna push to try. It's gonna do the baseline set of tests. I'm gonna push to try again, but with the yeah, here we go. That's enough. Roll back. Okay, so here's how I okay, and then let's try again. Mock try again. We'll just use the same task as last time, which is great. And then what I will do is I will create a commit where I have put the change to the helper function, which is vim browser base content test WebRTC head.js promise device promise request device. Yes. Then we'll do that. Request device. Return. So let request equal that. Special power spawn request device. I'll do is I'll await this, and then I'll await special powers promise focus window. See if that works. Just to double check, that should allow us to run the tests when we are running with the display. No, promise focus is not a function. Whoops. I'm glad I checked. Special powers. What was it? Oh, it's simple test. It's not special powers, it's simple test. So many utilities. Try again. Perfect. All right. I'm more confident now that this should just kind of work per expectation. Whether or not it fixes the thing, potential test fix, is unclear. But we can now compare them. Apparently running my commit hooks are running, and so it's running a bunch of linting. Cool. That always takes a little bit of time. No problems. Great. Okay, well, I hope that was interesting. The we went into my need infos, we cleared some out. We didn't clear all of them out. We didn't get to the video controls thing I wanted to. Here, I'm going to do try again. Potential test fix. But I hope you saw some interesting stuff. And the takeaway message is printf debugging is okay. There's nothing wrong with that. Whatever gets you the information you need. I think that's what's important, is getting yourself the information that you need in order to get your job done. I'm going to call it there. Hey, thank you so much for watching episode 200 and whatever this was of The Joy of Coding. Let me just figure out what it was. Episode 279 of The Joy of Coding. I hope that was interesting. I will see you next week. Where... Oh, hold on. I didn't get to some questions. Hold on. There were some questions. I'm going to try and clear these out really quickly. Questions. These were questions sent from the forum, and you can send me questions as well if you choose rate this episode. Tell us about the Tabertle Firefox add-on that posts on your Twitter, please. Yes, so you may or may not have seen me tweet. If you follow me on Twitter, I have a Twitter account. One of the things I have tweeted recently, or been tweeting recently, are tweets like this, which is, not Wordle, just my Firefox tabs. And it's a representation of my Firefox tabs in the grid that sort of the Wordle offers. And I think this is, I don't know why it's like the spacing's so odd here. I think characters, what's happening? I don't know why. I might have to talk to our graphics team. Why is there a gap here and not here? No idea. But the Wordle sort of grid is being, I'm taking advantage of the popularity of Wordle right now to, promote this add-on I wrote called Tabertle, which will take your current Windows tabs. It will add this button. Here, I got this green button. And when you click on it, it will capture the tabs of the window and create a grid, a Wordle-like grid, where each color represents a different state of the tab. Purple is pinned tabs, green are tabs that are loaded in memory, and yellow are tabs that are unloaded in memory. And as you can see, I had a big block of tabs that were not loaded in memory, except for a couple here and there. And then, if you have too many to fit into a tweet, it'll truncate it at the end with an ellipsis. It's a free add-on. I wrote it for people who are interested in tweeting about, their Firefox tabs, kind of being like Wordle. So check it out. That's just a quick plug for the Tabertle Firefox add-on. I swear I did not put this question in as my own plug. Someone legitimately asked that question, so there it is. Any thoughts as browser as a service? I'm not sure what that is. We can briefly do a search, like browser. What is browser? A web browser hosted as a service? Is it this? Is this what people are talking about? Browser as a service? I have no idea what this is. It's a headless browser through a REST API. Oh, I see. So running on a different machine. So yeah, okay. There are. I think I know what the idea behind this is. There's an example of this. I know people who are working on something called Mighty, Mighty browser app, which is kind of like this idea where like you render the UI of the web browser, but what's actually happening is it's basically like a video stream. And the browser is actually running in a cluster on the internet somewhere, and that's what's doing the actual network requests and downloading HTML and JavaScript and CSS, executing it, rendering it, and then sending you the frames. In fact, Opera, I believe, may have pioneered this for their Opera Mini browser on mobile devices, because what they were offering was like, basically it's like a service where the phone would just download images, static images of websites that had been downloaded on Opera's machines, downloaded, rendered, etc., and then they send you the images, and then you could like click on them. So my thoughts on that are that's a very interesting solution to the problem of I need to do, like, browsing computation has gotten really heavy, and it's nice if you can take advantage of beefier hardware that's not necessarily associated, like a thin client. It's basically the idea of the thin client. I think it's an interesting idea. My one reservation is around privacy and security. Like the idea that the browser is such an important part of my daily life, at least, but I think many people's daily lives. And imagine your browser tabs are running in the same user space. Like, I don't know what the sort of browser as a service, maybe it just is like your own stuff, in which case great. If you're paying for that and it's on a machine and it's running only your own tabs, and you are confident in the service is treating your data nicely and it's secure, that's great. I think that's a great idea. If it's like intermingled with other people's stuff, it's running on machines, it's other people's tabs as well, I would be very cautious. It's not impossible to keep those things segmented and away from one another with different executable, different processes, or even different virtual machines, but I'd want some guarantee that my data is being respected and my privacy is being respected, and that it's not possible for another user of that browser service isn't going to somehow breach the walls and have access to my browsing data. I think those are my thoughts on browser as a service. If I understand the question, that's how I'm interpreting the question, is like thin client browsing, kind of like Opera Mini or that Mighty thing. So those are my thoughts. I think it's an interesting idea, but there are trade-offs with respect to security and privacy that I think need to be thought through. What'd be really neat is if you could have like a beefy desktop at home that does your browsing and computing and surfing and stuff, like a really, really beefy device that you connect to from wherever you are, and that device, which you own and run and can maintain, does your surfing for you. It has your like fiber internet connection, and then whenever you're on the road, maybe if you're using your phone, you can connect to your device at home and not spend so much energy doing computation on your phone or something. You connect to your beefy device, which does all computation and sends you the frames or whatnot. I think that'd be interesting. At least that way you own the machine. You own the data. You can be relatively confident that there's no one else using it unless you open it up for other people. Those are my thoughts. These are not very well structured, cogent thoughts. It's just what comes to mind. Send me more questions. Those were great questions. You can send me questions via the Rate This Episode form here in the agenda. And with that, I will call it. Thank you so much for watching episode 279 of The Joy of Coding. Ta-ta. I will see you next week. Take care. Bye-bye.
The joy of coding.
See ya.